All right, so our topic, next topic here, then we'll be going to tackle all about the forecasting. So let's define forecasting. It is generally refers to the process of making predictions or estimates about future events based on historical data and analysis of trends. So it is used across various fields such as the economics, finance, weather forecasting, business planning. So the goal is to reduce uncertainty and assist decision making by providing insight into what may happen in the future based on current and past data patterns. So for this one here, um, what are we trying to do in forecasting as we're absolutely checking or the based on your historical data, you wanted to forecast the future trend if there will be a downtrend or uptrend for that one. If basically if you wanted to deal with the heat index in the future, if it will be going to worse or it will be going to decrease, something like that. You are absolutely looking for something or looking for the trend or seasonality, it could be, or the cycle for that. And here there will be a specific steps that you will also deal with regards to that. And there's a lot of slides that we'll be going to tackle with today. So for the steps, it is definitely defining the objective, gathering the data, exploring for processing the data, choosing a forecasting method, and splitting the data into training and testing sets, and model training, then validate and evaluate the model, and generate the forecast, and monitor and update, and communicate results and uncertainty, iterate and improve. So let's take it one by one then. For this one, defining the objective, we have to clearly define understand what you aim to forecast, such as sales, demand, production, or other business metrics. So this is the time that you're absolutely checking or spending a lot of time to brainstorm what will be the problem or what will be the topic that you wanted to achieve, that what will be the focus of your study. So gathering the data afterwards, you have to collect historical data that will be the foundation of your forecast. And this data is can come from internal sources, sales records, and it could be inventory data or external sources, market trends, or economic indicators. So absolutely in your MS team, I was able to give you the specific links where you could definitely check or where you could be able to get some of those data sets. It could be in Kaggle, it could be in UCI Machine Learning Repository, or it could be in Google Data Search, Dataset Research, Dataset Search, or it could be in DataGov or OWS Public Data Set 538 or World Bank Data, Open Data Portal, UN Data, everything. There's a lot of site that you can get or gather those data sets or that suits into your topic as well. So exploring and processing the data after you've established the data set, you were able to get the data set, you can perform exploratory data analysis right now to uncover trends, pattern, or outliers. You have to clean the data by handling missing values or outliers and ensuring it is in the correct format. So that is really necessary because in order for you to check establish if your data set if it is ready or for the implementation already. So even that you can definitely see in your CSV file that your data set is already good, but you need to really run through if those missing values, those outliers, is what will be basically the thing that you could also improve if there would be such thing vulnerabilities in the future in your data sets in the future, if you could find that out as well. So of course, you need to after calling the data your data set into the data frame, that's the thing that's the time that you can deal with the implementation of the pre-process technique. Now you have to choose a forecasting method as well. You have to select the appropriate method based on the data type and problem context, such as time series method, regression, or machine learning approaches. You know what? There's a lot of types that we can deal with later on. That you can definitely, if it is in terms of ARIMA model, if you're dealing with the time series methods, could be Holtzman or exponential smoothing, something like that. There's a lot of them. So you have to split the data into training and testing set. That is really important as well. You have to divide your data into training and testing data set. The training set is used to build the model, while the testing set is used to validate the performance. So in this case here, that is really necessary for you to for the training set, it could be 80%. For the testing, it could be 20%, or 70-20-10, or 80-10-10, something like that, if you are splitting that into three splits. But here you also you're supposed to split that into 20, I mean two testing set. So for the training set, it will be that will be your uh set that you need to train the data in the future in order for you to extract amount of data. What will be, if there will be a downtrend, it will be a uptrend, something like that. And for the building I mean for the testing set, that is the validation of your validation steps that where you could able to use the mean absolute error, the R squared, or the RMSP, something like that. And for model training, train your forecasting model using the training data. This is the stage where the algorithm learns the patterns and relationship within the data. So you can actually train your model. It could really take a lot of time. It could take days or how many hours to really extract a certain amount of data for that one. So that is really necessary for you to, in order for you to really extract those amount of data. Now, afterwards, you have to validate and evaluate the model. To test the model using the test data and evaluate its performance, like the standard evaluation metrics like the mean absolute error, root mean squared error, the mean absolute percentage error, or the MAPI. There's a lot of evaluation technique ability that you can use as well. So afterwards, you have to generate the forecast. Once the model is validated, you need to generate the forecast for future periods based on historical data. That's the time that you can check if there will be a fluctuation into your results. Now, you have to monitor and update as well. You continuously track the performance of the model over time. You have to update the model regularly to ensure its accuracy and incorporate new data. Then you have to communicate results and uncertainty. So you share the forecast result with your stakeholders as well and communicate any uncertainties or associated potential risks, and that will help in making informed decisions. So that is really important that you need to always monitor and update if there will be a necessary thing that you can deal with, because for example, if there will be outliers that will still happen, so or overfitting or underfitting that may that you may encounter, you can definitely check with the possible solution or possible thing to consider with. Then the last thing will be the iterate and improve. So for that one, based on feedback and the forecast performance, I iteratively refine and improve the model. This might involve in adjusting the model using the new methods or collecting additional data. So this time here, you have to check the performance of your model, if that is linear or whatsoever it could be. Now, let's deal with the methods of forecasting already. For the methods of forecasting, that includes with quantitative and qualitative. So I know that you're already familiar with this. When we say quantitative forecasting, this method uses mathematical processes such as algebra, permutation and combination, set theory, matrix algebra, and integration to analyze and predict future events. So sort of the example will be the time series model, regression analysis, ARIMA, that is ARIMA, and machine learning based forecasting. So here then actually, excuse me, we're absolutely talking to numbers. And for qualitative forecasting, this method is subjective in nature and relies on judgment or intuition, expert opinions, emotion, or personal experiences rather than numerical data. So common example will be the Delphi method, market research, expert judgment, and focus groups. So for this one here, we're definitely doing the in qualitative forecasting, you're doing or checking the perspective of specific individual, it could be like that. And for the types of quantitative analysis or forecasting, there will be a time series model and associative model only. But there will be a subtype and there will be a, for each subtype, there will be also sub type as well. So here then, for time series model, straight line method, moving average model, exponential smoothing, and exponential smoothing, may arap na siya. Double hold, simple hold, something like that. We'll be going to deal with that later on. And for the trend projection, it could be the Arima or Sarima or Arima or whatever. There's a lot of excuse me, subtypes for that as well. Now, for associative model, there will be a simple linear regression and multiple linear regression. So that's the thing that you will build for the quantitative model. So for this right now, let's go next. For the time series model, when we say straight line method, it is simple forecasting method that assumes a linear trend in data. So there is a trend that will begin to deal with that. And moving average, trend linear, I mean. And moving average uses average of past data to predict future values, often smoothing out short-term fluctuations. So we'll begin to deal with that one by one later. So exponential smoothing, a weighted average method that gives more weight to more recent observation. And for trend projection, that is a method that fits a trend line, like linear or exponential, to historical data to forecast future values. So let's actually move on to the associative model, which is the simple linear regression. It is a model that predicts a dependent variable using one independent variable. It could be multiple linear regression as well, which is paving the extension of simple linear regression that uses multiple independent variables to predict the independent variable. So we'll be going to deal with that as well in the future. So for Delphi method, for the types of qualitative, there will Delphi, market research, panel consensus, visionary forecast, and sales forecast composite. So what we'll be going to deal with today will be, there will be a Delphi method, which involves gathering expert opinions in a structured manner, where experts revise their forecast based on feedback from others. So they're using basing in the intuition of the other individual as well. So what will be the feedback of the other? So they are relying on that basically. For the market research, they are using surveys, focus groups, and other techniques to collect information from others, from customers or potential customers. So what are we trying to deal with here? So for example, you are checking surveys, what will be the surveys result, what will be the sentiment analysis for the other individual. You are basing on that one. That will be the result for the forecasted data. Now, the panel consensus, experts or managers come together to discuss and agree on a forecast. So say, for example, in a desired sales in the future, your manager wanted to forecast that in the future, you want to achieve 80% of sales. So that will be your forecasted data in the future. You wanted, that is your main goal in the future. That is the panel consensus it takes place. For the visionary forecast, based on intuition or creative insight, often used for forecasting long-term or emerging trends. So there is a positive, there is a designated goal in the future that you're relying on in that specific instance. And afterwards, the sales force composite, which is the method where sales people provide forecasts based on their understanding of customer demand. What will be the demand? They are basing on the demand. If it is high demand, they are setting a specific forecast for that. If there is a low demand, there will be a specific forecast for that one based on the impression of the demand as well. Now, we'll be going to deal with the time series model in the next slide as well. So time series model. This is absolutely a method involving analyzing historical data to predict future values of time-dependent variables. The core assumption of time series forecasting is that past patterns, such as the trends, seasonality, and cycles, can be extrapolated to predict future values. It is popular forecasting model that explore past company behavior to forecast future company behavior. That means to say, here then, we are using the previous historical data in order for us to extract the certain amount of trend, or it could be a seasonality in the future. So the first thing that we'll be going to deal with that will be the straight line forecasting model that I'll be going to deal with that in the next video. So see you then.